Hello everyone, in this video we will derive the volume of a cone. So what is a cone? A cone is a shape with like a circular base. Let's say it has some radius r and it has this triangular shape, and let's say it has some height over here h, and along the cross sections of the cone it's all circular, right? So it's like kind of a circular object heading upwards. Let's say it has a height of h and a radius of r. So how do we get the volume of this cone? So we'll use a similar idea as we did to get the volume of the sphere. So where we'll take the volume of these individual cross-sectional small circles with some radius r and some height. Let's call this height d sub x, as not to conflate with this h over here. So we'll take this volumes of these small cylinders here and integrate by adding up all the volumes of the individual small cylinders up to the top, right? So here, let's say our x, or basically x is the height from the base to a point. So here our x is 0 because we are at the base. Then the radius of the circle we want to use to integrate is r, right? And here, since we're at the top, our x is equal to h because we've defined h as the height of the cone. Then the radius of the circle we want to use to get the volume at this point is equal to 0, right? And so given any arbitrary x, right? So let's say we draw a triangle here, which is basically, you can imagine this part of the cone, the middle section of height h and radius r. Then at any arbitrary height x, we want to be able to compute or come up with a formula for r sub c, right? So how do we do that? So if you notice, this is x, and this over here will also be x, and this part over here will be r minus r sub c, and this part over here will be h minus x, right? So we have the whole thing is h, this is x, this is h minus x, the whole thing is r, this is r sub c, this is r minus r sub c. So we want to find the r sub c in terms of x, right? Because we want to integrate using x. So we know that this angle over here is constant, right? So meaning the tangent of this angle, which is opposite over adjacent, will remain the same. So in this case, opposite over adjacent is r over h, right, for the bigger triangle. But then if you look at the smaller triangle, we have opposite over adjacent is equal to r sub c over h minus x. And from this we can solve for r sub c. So r sub c is equal to r times h minus x all over h, right? And r and h here are constants, so we can simplify this to r, because these will cancel, minus rx over h, right? R minus r over h times x. So that's our formula for r sub c. So now that we have a way to get the radius of the cone, right, at any given height x, all we have to do is integrate, right? So it's going to be the integral from x equals to 0 to x equals to h, and this integral, inside the integral, will be the area of the circle with r sub c, so that will be pi r sub c squared, and the height, the minimal height here that we're taking, is dx. Now we have written r sub c in terms of x over here, so we're going to substitute that. It's going to be the integral from x equals to 0 to x equals to h of pi times r minus r over h x squared dx. And so now let's evaluate this integral. So evaluating the integral is going to be pi, which is the constant, times the binomial here is basically r squared, this is still integral, so integral from x equals 0 to x equals h. So we have r squared minus 2 r squared over hx, that's basically the product of these 2 times 2, plus r squared over h squared x squared, that's basically the last term squared, dx, right? And so now we just take the integral of this, so it's going to be pi times integral of r squared with respect to x is r squared x. Integral of this is going to be 2r squared over h, and this would be x squared over 2. And then the integral of this will be r squared over h squared times x cubed over 3. And we have to evaluate this from x equals to 0 to x equals to h. So now let's evaluate that. So we have pi, so plugging in x equals h, we have r squared h minus 2r squared h squared over 2h plus r squared h cubed over 3h squared. So this is evaluated at 0, and then we'd have to minus that was evaluated at h, and we'll have to minus evaluating at 0. So this becomes 0, this becomes 0, this becomes 0 because x is 0, so we actually don't have to evaluate it. And so now if we simplify this, we'll have pi times r squared h, 2h will cancel over here, so this becomes minus another r squared h, plus this one becomes r squared over 3, r squared h over 3, right? So these two are the same, so we end up with pi r squared h over 3, and that is the volume of the cone. So I hope you enjoyed this derivation, and stay tuned for the next video. Cheers.